Hey everyone, before we get too deep into today's episode, just wanted to say apologies for this episode being a bit shorter than normal. I am recording this at the time of the previous episode, so I'm recording this a week in advance rather than a few days in advance. That's mostly because my schedule is super packed right now, so I'm just taking the chance to record this while I can because I don't really want to miss an upload. Hopefully next week I'll be back to my normal schedule and we'll have slightly more longer episodes. But yeah, we'll see how it goes. And yeah, hope you enjoyed the episode. Hi everyone, welcome back to another episode of Blockchain and Beyond. As always, I'm your host Farzan. And on today's episode, we're going to be discussing smart contract languages. In particular, we'll be looking at Solidity, Rust, and Teal. So in our last episode, we discussed decentralized applications, smart contracts, and how they all fit together to create blockchain-enabled tools. And today we'll be discussing some of the different smart contract languages, how they differ, and where their functionalities actually differ as well. So a quick recap on smart contracts. Smart contracts are a piece of code which function as programs which are stored on the blockchain and run when predefined conditions are met. Typically, they are used to implement agreements among participants, giving them immediate outcomes without any wastage of time or the requirement of a middleman. Smart contracts can also streamline multi-step procedures by continuing to work when conditions are met. So the key part here is that smart contracts are programs, meaning they are written in code. Each blockchain has certain languages which can be used for its smart contracts, and that's what we'll be discussing. The first one we'll be discussing today is Solidity. So Solidity is an object-oriented programming language for writing smart contracts on blockchains, most famously Ethereum. At its base level, it's heavily influenced by JavaScript, Python, and C++, and Solidity focuses on the Ethereum blockchain. It is in fact the most popular smart contract language, and this is also due to the fact that Ethereum itself is the largest smart contract platform available. So to understand how the smart contracts actually work, embedded within each node of the Ethereum network is an Ethereum virtual machine. This virtual machine is considered to be Turing complete, which without going into too much detail means it can perform any of the logical steps associated with the functions defined and will not get stuck in any endless cycles. And this is important for the protocol as it allows each node to come to the same conclusion given a smart contract, enabling them to reach a consensus. However, the Ethereum virtual machine comes at a cost. In order to execute a smart contract or any of the steps involved, you must prepay the network for this opportunity. Once paid for, the nodes on the network will carry out the actions associated with your code. There are other languages which can be used on Ethereum, such as Viper or Serpent. These are both based on Python, hence the snake naming convention, and the code can be translated into a form which can be read by the Ethereum virtual machine. For anyone interested in learning more about Solidity, there's an interactive learning resource called Crypto Zombies, which I've used myself, and I'm learning a bit of Solidity as I go along. And this is an interactive platform which takes you through the steps of writing smart contracts for different data types, and it all leads up to the creation of a game. The next language that we'll be discussing is called Rust. So Rust is a language which is supported on Solana, Nair, and Polkadot, all of which are blockchain projects, and the language itself is based on C and C++. Like Solidity, Rust is also Turing complete, meaning it won't get stuck in loops and will always resolve in an outcome. The big benefit of Rust is that it is the go-to language for Solana, and currently Solana boasts a much higher throughput compared to Ethereum. This makes it an attractive language for those wanting to move to a faster or less congested network. Due to the way that Rust manages its code, it often results in much smaller files, which would make it cheaper and faster to execute on the blockchain. However, Rust doesn't include some features such as garbage collectors, which is an automated way to manage memory that is being used by the program. This requires the programmer to carry this out themselves, which is a manual process and can generate errors if done incorrectly. Overall, Rust is actually more error prone, and this is exacerbated due to the way it is written. The syntax in the language is much more difficult for newcomers to grasp, and to understand the full functionality of the language. That being said, it is one of the most popular smart contract languages based on GitHub stars. And for those who are unaware, GitHub is a platform for people to host and share code with one another. The third language which we'll be discussing today, and slightly different from the others, is called Teal. So Teal stands for Transaction Execution Approval Language and is the main smart contract language for Algorand and the Algorand virtual machine. Teal outlines a set of concise operations from which the user cannot deviate from, or not too much at least, and it gives the user all the tools they need to create a well-functioning smart contract while minimizing the chance of coding errors. Similar to the others, Teal is also Turing complete, but unlike the others, it is based on assembly, which is a much lower level language, which can make it more difficult to work with. However, recent advancements in the Teal language, such as the Teal 4 update, makes the language better suited for those coming from a background of Solidity or JavaScript, whilst maintaining its assembly roots. The Teal 4 upgrade also enables 512-bit arithmetic operation, compared to Solidity's 256-bit operations, making it possible to write algorithms which utilize much more complex logic and create more sophisticated products. And more recent upgrades to the Teal 5 system have made it possible to have smart contracts which can auto-compound rewards. So this is a function which we'll primarily see on DeFi platforms such as Yearly, where a user can deposit their assets and the Teal 5 smart contract will compound their rewards automatically. Prior to this, users would have to manually claim their rewards and then restake their rewards. So not only does this reduce the number of transactions on the network, it also enables users a much more friendly experience. And that covers the three main languages I want to cover. Obviously, there's a lot more languages which I could have covered, such as Bitcoin script, Go, C#, Haskell, or Clarity, and this is just a small dent in the number of smart contract languages available. What I think one of the best things is that no matter which language you come from, there is most likely a language which will be based on the language that you're used to, meaning it will be much more easier for you to pick up the language and learn how to implement smart contracts onto the blockchain without having to relearn everything from scratch. And yeah, that brings us to the end of this episode. I hope you enjoyed this episode. As always, if you do have any questions, feel free to reach out to me. It would be great to hear from you. If you have any suggestions on what you would like to hear about next, again, feel free to get in touch. I will be happy to look and see where it fits into my schedule, my current plans. And yeah, thank you very much for listening, and I hope to see you guys next week.